Hello and welcome to Terminal House Media. I'm the operator, and I hope that you all are having a great night, great day, wherever your time zone may find you. I hope that you're living it well. Tonight, I am going to pick up where I left off yesterday night, and I did not save that stream because unfortunately the audio was absolutely horrible. But tonight what I'm going to be doing is going through and reading some basic documentation. I want to configure a high available stateless lab environment using a tool or software parallel file system called HPC. So I'll be doing some reading through that. I'll be doing some drawing to show how I'm creating my topology within my home network. And this is kind of where I got spun up yesterday. I'm new to Excalidraw, and I decided to just start drawing and creating without knowing how to save. So I am starting from scratch, from the very beginning, from the bottom of the hill, and I need to climb my way up and build this topology out using Excalidraw while I have the free subscription. And then next, if you've seen any of my videos, you're very familiar with my very basic environment. I don't have a lot built out, and previously I did have some servers that I had some good restore points on that I used for studying for Red Hat. And after I passed that, I just kind of deleted the entire environment, kind of moving on to a better build, a more robust build. So that's what you're going to be watching here. And if you look to the right corner, I'm going to do my best to show what I'm doing with current task and also these notification indicators that you can see to the right. If I have the time, I will add the timestamps at the end of the live so that you can search through and find whatever you need to. But other than that, this will be the visual timestamp that you are able to see everything with. All right, let's get started. I don't want to bore you all too much. So this is just my study environment and the way that I learn. And the biggest thing to take note of is this is a learning process, which is why I'm showing you the documentation that I'm reading from and being as transparent as I can about what you're going to experience in this. It's a trial and error. So I'm just trying to learn as many skills that I can for work, so I keep a job, keep food on the table, and enjoy life. All right, so Warewulf, I'm just going to read this off so people who aren't familiar with what Warewulf is, you can see it. So Warewulf is an operating system provisioning platform for Linux clusters. Since its initial release in 2001, Warewulf has become the most popular open source and vendor agnostic provisioning system with the global HPC community. Warewulf is known for its massive scalability and simple management of stateless disk optional provisioning. And so that's kind of what we're focusing in on is not necessarily the scalability, but the simple management of stateless provisioning. Okay, and Warewulf leverages a simple administrative model centralizing administration around virtual OS images, which are used to provision cluster nodes. This means you can have hundreds or thousands of cluster nodes all booting and running on the same OS image as of Warewulf version 4. The OS image can be managed using industry standard container tooling and or CI/CD pipelines. This can be as simple as Docker Hub or your own private GitLab CI infrastructure. With this architecture, Warewulf combines the best high-performance computing, HPC, cloud, hyperscale, and enterprise deployment principles to create and maintain large, scalable, stateless clusters. So another interesting thing within this documentation, let's see, Beowulf. Okay, so Beowulf overview. Warewulf is designed to support the original Beowulf cluster. What is Beowulf cluster? Glad you asked. So, Beowulf cluster is from Wikipedia. A Beowulf cluster is a computer cluster of normally identical commodity-grade computers networked into a small local area network with libraries and programs installed that allow processing to be shared among them. The result is a high-performance parallel computing cluster for inexpensive personal computer hardware. So you can see it just got a bunch of desktops all connected, and there's another interesting piece inside of this documentation where they talk about drift and why Warewulf is actually useful. Let's see. Okay, why stateless provisioning? This is really good. Okay, and I'm going to do this. Why stateless provisioning? This is what I want to implement into my network, into my home environment. Warewulf further improves on the automated provisioning process by skipping the installation completely. It boots directly into the runtime operating system without ever doing an installation. Stateless provisioning means you never have to install another compute node. Think of it like booting a live OS or a live ISO on nodes over the network. This means that no node requires discrete administration, but rather the entire cluster is administrated as a single unit. There is no version drift. This is what I was talking about. Because it is not possible for nodes to fall out of sync. Every reboot makes it exactly the same as its neighbors. Yeah. That's pretty cool. Okay, so what I want to do is go previous. There's another part where they talk about the drift that I want to read. I guess it's not on here. Maybe it was on the Beowulf page. I guess there was a portion on here that I read earlier that actually talked about, gave a little bit more reasoning as to why Beowulf was kind of replaced with Warewulf. Okay, well, okay, so operating system images provide a bootable image, including the kernel that will be used to boot the cluster node. OS images provide the base operating system, by default run entirely in memory. This means that when you reboot the node retains no information about Warewulf or how it booted, but it also means that they return to the initial known good state, which is why I'm going to use a provision or stateless environment for my testing and my labbing. I'm going to be stateless provisioning within my labbing environment. The only requirement to provision a node with Warewulf is that the node is set to PXE boot. You need to change the boot order if there is a local disk present and bootable. This is a configuration change you will have to make in the BIOS of the cluster node. This configuration is different for each vendor platform. For more information, consult your system documentation for your hardware or vendor support. Now, this part is pretty important because I believe, now, like I said, you are watching this and you should be aware of the fact that you're watching this and I'm learning. But I believe that I'm going to have to create these virtual machines as though they're without any images or no ISO. Make sure that the VM is set to PXE boot and make sure that it is within the same VLAN that I am creating my Warewulf head node. So I guess that's my interpretation of this portion. All right, so now, hardware vendors are often available to pre-configure your cluster nodes with values of your choosing. Ask them to provide a text file that includes all the network interface MAC addresses of the cluster nodes in the order they are racked. This simplifies the process of adding nodes to Warewulf in the order of which they are racked. It's good to keep on reading. The provisioning process. When a cluster excuse me. When a cluster node boots from Warewulf, the following process occurs. The system firmware, either BIOS or UEFI, initializes hardware, including local network interfaces. The system uses an in-firmware PXE client to obtain a boot P or DHCP address from the network. That would be from the head node. The DHCP server, hosted either on the Warewulf server, or externally, responds with an address suitable for provisioning, along with the next server option directing the cluster node to download via TFTP and execute a bootloader, either IXP or grub with a Warewulf provided configuration. The bootloader configuration directs the cluster node to download and bootstrap the configured kernel image and overlays from the Warewulf HTTP server, head node, and a single stage provisioning configuration. The desired image and overlays are combined and provisioned immediately by the bootloader as the kernel's initial root file system. This is straightforward but does not work in all environments. Some systems have memory layouts that are not handled properly by either iPXE or grub, or sufficiently large image sizes, leading to strange, unpredictable results. In a two-stage provisioning configuration, a small initial root file system created by dry cut is provisioned first, and this image uses the provisioned Linux kernel to retrieve and deploy the full image and overlays. Perhaps counterintuitively, the two-stage provisioning process is often quicker than the single-stage process because the Linux environment is more input-output IO efficient than the bootloader itself. Optionally, including configured overlay www client, it is left resident on the cluster node and periodic refreshes configured runtime overlays. Okay. A cluster resource depends on a cluster network. This network can be either persistent, it is always up, even after provisioning, or temporary, only used for provisioning and or out of band system control and management. And or out of band control management. Example, IPMI. Let's do this. Copy. Sorry about that. I gotta resize the screen. It's just so big over here. All right, so let's copy this into here. And pull that. Control C. Control V. I am building a stateless Linux lab environment within within Proxmox VE 9.2. I will be drawing my network topology on Excalidraw. I know I need to create VMs in a segmented network. VMs. I need to create a bastion node, really, which is, I'm not going to use AML Linux as that. So I'm going to need to create, I know I need to create a bastion node, which is going to be my jump box in between the two networks, a segmented network for my worker nodes, a head node, and my worker nodes, which would be AKA my Linux labs. And then yeah, I think that's a pretty good start. So clustered, and I need to understand what IPMI is. YouTube is not receiving enough video to maintain smooth stream as much viewers will experience buffering. All right, well, I hope everything is all right. Okay, what should I produce for you right now? Written network. Basic concept on how to execute this plan. Then I will draw it out on Excalidraw. How many worker nodes and what's your current Proxmox network setup? With Black Bridge, there we go, 1. Okay, and it's asking what is my network setup, so I'm going to show that. And I'm going to delete node 1. That'll eventually that'll be rebuilt within the segmented network 101. And we're gonna go back to Alma Linux, Alma Brain, and let's go to the data center. This. Do a little snapshot of what we got right here. I'm gonna put that in Claude. And I also want to put that within there. This one. This can help us refine our config. So I'm gonna think we can consider ourselves to be on the next stage of what we're doing. All right, so let's see if I can make things a little bigger. Okay, so this is pull back up. Good. This confirms that the single physical Proxmox node, Hornet's Nest, 24 virtual CPUs, and about 58 gigabytes of RAM, 94 gigabyte root, and secondary pool of 888 gigs. That simplifies things. No physical network segmentation needed between host, bastion, head node, and all workers will be VMs in this box, and the segmented network is purely a second virtual bridge. Right. Here, how would I carve up resources given what you have? One CPU, need 16 gigs. Virtual bridge 1. Yeah. Then head node. Oh, so head node access the bridge. I don't need a bastion node if I have that. Just makes no sense. I don't need the bastion node if the head node is dual network. So we got the head node and then the worker nodes. One trade-off worth noting, the head node is now your single point of entry and also runs DHCP, TFT processors, harden it. Oh yeah. Oof. Never mind. Let's use the Bastion node. So the Bastion node becomes a DMZ. Essentially, I guess. I didn't think so. Never, because everything else is flex. As everything else is external legs, so it shares a broadcast domain with your homeland and the head node. A real DMZ implies a separate segment that's firewalled on both sides. Untrusted network can only reach the DMZ. Can only, two ways to actually. Cheap version recommended. So we're just going to do. I still don't want my head node having to do everything, so I'm gonna run with this configuration. I'll keep the Bastion node config. All right, so now I think I'm ready to start working on Excalidraw. Get my server information. Okay, so now that we have a lot of the information that we need, see our system is running pretty good. So what I'm gonna do is I'm gonna go over to Excalidraw and I'm going to begin creating my what do you want to call this? Topology chart. Sorry. My mind is blanking because I am looking for a color that I don't see. I want to use yellow, but we'll go with orange. All right. So let's zoom out as much as possible. And like that. And we're gonna call this undo that, go right here, go extra thick, and we'll call this terminal house media. Jesus Christ. Okay. Let's just not do it like that at all. That was a bad idea. Anyways, I'm gonna go like this and call this terminal house, and terminal house is internet. Right, terminal house has internet. It's still visible. Let's put that right there. Okay. Terminal house has internet. Who is my internet service provider? Let's say none of your business. But I do have an internet service provider. ISP, internet service provider. Oops. Control Y. There we go. This. I'll do that right there. And I have a. Let's see. Trying to think of what kind of line comes into the house. All right, so let's do this, and we're gonna do all right, so we've got a coaxial coming into the house. And then from that coaxial, that is on another wired network. And let's just do, I'm gonna do green. No, oops, that's not what I want to do. Blue. To this, and oops. Okay, I am learning Excalidraw, so bear with me, please. And I want to make that a lot bigger. Okay, so RG6 coaxial, And then that comes into the house. And there we go, the Claude didn't change it. And we're gonna, I said I was gonna make that green. That goes into the house and connects to my modem. All right. And all right, so then we got RD6 coaxial inside the house. And oh my gosh. Text, type, modem, and from the modem I'm using Cat5. I want yellow. Such a limitation on colors. Excuse me. I got it. Take a sip. All right. Well, I guess yellow is not available. That's really annoying. That's really annoying. That'll be my cat 5. The color schemes are kind of a bummer. Uh-oh. Whoa. All right. Just create one. This purple. This is not that. Please don't start getting annoying. Oh, you're getting annoying. Oh my goodness. That's the way we've got to do it. That's the way we've got to do it. All right, so then that enters, let's put this here. That connects to my router. All that just to do this, Jesus. So good to me. Why are you filled in? What's that color? We're so limited on colors. I am not a fan of how limited we are on colors. Anyways, right. I got yellow. Okay. All right, so we're gonna make that yellow. I'm gonna make that. Yellow. Then my router. Router purple. All right, so now that we're at the router, we're going to use another Cat5 cable coming from the router. Into my Proxmox host. And that is gonna be just like this. I think that's a great size. Put that right there. Okay, and I want to put information that is needed for this. All right. So this is the system that I'm using. It's my Proxmox host. Let's see. That's not what I want to do. Trash. And let's see. That's not what I'm trying to do. I'm trying to upload an image. Ah, it worked. Okay, then take this guy. Okay, and let's get that around information. Oops. All right. I'm still making progress. I just want this to be as thorough as possible. Oh God, I don't like this. Okay, so then next thing I need to do is, oops, create my segmented network. How do I want to do this? First of all, let's dark mode is a lot better. Anyways, so trying to think about how I want to have this displayed. Haven't used RAD yet. What I'm gonna do is draw out my main network. So if we go here and I go here, hardware, virtual management bridge 0 is gonna be VMBR 0 here. I need to do control save. Alright. So text white, and this is VMBR 0. Then we're gonna create red, Jeez, man, this thing is kind of annoying to work with. Alright, so like, why is this color now? Oh my god. There we go. This is not right. Okay, well, I guess now yellow suddenly doesn't work, but it was working before. That's also annoying. What the fudge? Caps F. Whatever. Why isn't this working? This is stupid. All right. I'm officially starting to hate this application. Like, I'm obviously clicking here. Hex code. Type in the hex code. None of that crap is working. That's irritating. What the heck is going on? Now you're messing up and you're taking my time. You're wasting my flipping time. All right. Don't like that. Golly. What the fudge? Why would I want only the colors that's on here? So now we can use, so what? Okay, so it looks like we're going to be sticking with this. That is really annoying. I don't know what, that was very time consuming. Sorry for my outburst. Control C, Control V. Oh my God, stop. Okay. Now let's do. Oh my goodness, that is so weird how I just did that. I'm gonna call this VRB, Virtual Management Bridge 0. Kind of want to make that a little bit smaller, easier to view. Okay, so Control save that. Oh, it's just downloading. Anyways, whatever. Okay. So this is, now we're gonna go back to text. We're gonna put that block. We're gonna put this here, and we're gonna do VMBR 1, Virtual Management Bridge 1, and here we have various purple, red, green. Just gonna stick with the black then for these VMs. For the VMs, we're just gonna use black, and I have Alma Brain. Control C, Control V, and then I'll have the Bastion node, and Control C, Control V. Then I'll have my head node, all right, Control C, Control V, Alma Brain, Bastion node, Control V, head node, Control V, worker node 1, Control C, Control V, worker node 2, Control C, Control V, worker node 3. And now I'm gonna go back to text. I'm gonna go here, and this is Alma Brain. Here is more text. Bastion node. Text. Head. Node 1. If I ever expand, there'll be head node 2, head node 3. So, and then what we'll do is
I'm going to use, oh my god, man. It's kind of giving me a little headache right now. Rocky Linux for my lab environment. Control C, Control V. All right, and so far that is going to be my starting point of what I'm going to try to create. All right, so what I did was take a screenshot of my topology that I just created. And I've added that into Claude, basically acknowledging what I want to do. So I believe the next step will be to create the virtual management bridge 1. And then I'll create the Bastion node and the head node. And then I'll create the 3 worker nodes. And I'll make those bare. And then I'll probably most likely configure the Warewulf server. All right, Warewulf actually already solves the stateless half of this. It's the mechanism that streams the OS image to the Rocky Linux workers at boot. That's what your head nodes VMB virtual management bridge 1 leg is doing via DHCP, PXE, HTTP. What it doesn't solve is persistent data. Since the workers boot into RAM with no local disk, anything a student writes, home directory, scratch files, installed packages evaporates on reboot unless something outside the node holds onto it. That's the actual gap you're closing with the storage solution. You've got 2 ways to close it, and at this scale, I'd start with the simpler one. Option A, NFS from the head node, recommended to start. Warewulf ships this as a first-class workflow. wwctl NFS, the head node exports home and shared paths. Worker overlays mount them automatically at boot. No extra VM uses. Option B, dedicated storage node. A separate VM on Virtual Management Bridge 1 running NFS or a network file system purely for storage, decoupled from the head node's provisioning role. Worth doing later if you want head node reboots, rebuilds to not risk student data, or if you outgrow 1 disk capacity IOPS. For 3 diskless workers on a single 1 terabyte NVMe, it's more infrastructure than you need right now. True, but for learning purposes, option B seems more intriguing. 2 things to flag on your diagram before you build. The B-Link SER is a 616 terabyte, noticeably fewer cores than the Hornet's Nest box we sized earlier, 24C if Bastion 1 CPU had no Linux Workers nodes is your plan, that's a 9 level against your 8 physicals. Since KVM oversubscribed is fine for bursty lab use, but worth trimming workers to 1 to 2 CPU. No, that link is just outdated, and they don't make the model as beefy as mine. What you see inside of the Proxmox UI is accurate. When I bought my mini PC, it was much more powerful than I guess they really wanted to sell, so now they make the machine a lot less powerful. So I can never find my exact model. Good, that resolves the CPU concern with 24C. 58, you have plenty of headroom for a Bastion head node, 3 worker nodes, even generously sized 2 to 4. Still stands, that's the right. Okay, but we need to keep in mind that I also have a server, Alma brain, that I am using to learn to code and learning Git. So I can put that information in there. Okay, cool. We're ready to build in Proxmox, then stand up the head node and run Warewulf server install. That's correct. That's correct. Let's create VM Virtual Management Bridge 1 and Proxmox 9.2.3. Hey, this might end up being just a really, really long stream. Of course, we're gonna do it through the web UI. All right. So we got Proxmox open. And we're gonna go to data center and click book actions. Data center, Hornet's Nest, system, network. All right, so let's see. So in Proxmox 9.2.3, to create this virtual management bridge 1, I'm going to go to my data center, to my Hornet's Nest, then to system, then network, and click create. And I'm going to do a Linux bridge, virtual local area network VLAN. name it VMBR1, leave IPv4 CIDR and IPv6 blank. Proxmox host. This stuff doesn't need an address on this network, only the head node. Via their own Nix config. Leave the bridge ports empty. This is what makes it portless, internal only, no physical. You can uplink, leave VLAN aware unchecked. Comment, provisioning network, isolated. Create, then apply the configuration button. Then click apply configuration. Do you want to apply the pending network changes? Yes. All right. So now what I just did was create the red network, the virtual management bridge 1. And so now what it's saying to do is go ahead and create the head node, which would be the Warewulf head node. So I'm going to go ahead and do that. And that's going to be on Rocky Linux 9. And I already have the ISO uploaded for that. So we're going to go with VMID 101. And we're going to go with Warewulf. Okay, done. Create the head node. VM. All right, so yeah, we're gonna create the head node. Okay, I'm trying to make this look as professional as possible, so we're gonna go with MGM management. MGM 01. Let's do that. wwctl 01. CTR Warewulf control 1. Nah, I don't like that. So MGMT 01. That's very common. Okay. Then the OS, we're going to use the, oh boy, I'm not on Rocky 10. I guess it is what it is. I gotta do what I gotta do. We're gonna use Rocky 10. Alright, so yeah, we're gonna go ahead and use Rocky 10. OS, Linux, all that's cool. System, machine Q35, LVM, eBIOS, and disk. Thinking about how large I should make this head node. All right. I just found out something that I needed for work. Anyways, let's go back. I was looking for a different answer and found what I needed. All right, let's go ahead and do 40 gigs here. And later I'll add another disk. I think what I'll do is definitely do a backup of this once it's at a good state. So then we've got CPU. We're gonna do one socket, 4 cores, and we'll put this on the host. And then I'm gonna go with next. And Link. Let's do 8 gigabytes of RAM. 8192. Then now we're ready for the network, and we're going to do all right, let's work on this section. All right, let's try that again. Create vhelm mgmt01. Next, Rocket 10, system Q35 BIOS LV UEFI. 40. For host 8192, no VLAN, and all right, so we're going to have to add the virtual management bridge later, the secondary one. Let's go ahead and finish. Then I go over to this, see when this populates. All right, so there, it's there. Now I'm on hardware, and I'm going to add network device, and there we go. Cool. Now I've just added all right, so now I just added a secondary NIC to my management server for Warewulf. All right, so now I can see both devices there. We're making good progress. this looks right for you, blah, blah, blah. Missing the data disk. You've got the 40 gigabyte. Oh, yeah. Well, I didn't add that yet. During the Rocky Linux install, when you would network virtual bridge to DHCP. All right. Okay, so we're doing really good. What I want to do is go to hardware. I'm going to add in my NFS mounts. So I'm going to add a hard disk, storage coming from here. I don't know if we're really going to make that 200 gigs, but we're going to do it because I have the space. For now. I'll just roll it with 200. Okay, just go with the flow. A backup of this is going to be huge. Okay, let's go. All right, so we've got the storage added. We've got the server created. Okay, I think the next step is building the Bastion and worker nodes, or should we provision Warewulf server? Makes it more sense to provision the hardware and get the client set up so that the brain can connect to the clients and the clients are ready to talk. All right. Well, I guess we're gonna configure Warewulf first. What time is it? 9 minutes to 12. How long have we been streaming? Only an hour and a half. I think we can easily configure Warewulf. All right. We're gonna configure our Warewulf management server. I think what I'm gonna do is gonna add this management server to excuse me. I'm gonna add this to my router so that it's got a good static IP. And so we're gonna go to the console. I'm gonna go ahead and turn this server on a different screen. I'm currently editing my router. Right now we're going to do the Anaconda installation of Rocky Linux 10.2. I'll let that go. All right. Welcome to Rocky Linux 10.2. So obviously I'm going to use English, installation destination. We're going to do the 40 gigabyte dev SDA. Depending on what you play with, the CPU. All right, I love doing this. This is really cool. I'm actually asking Claude. So I do want to use these machines for studying as lab environments, but I would love to use them as worker nodes for using AI models and seeing what I can generate with that too. So I'm going to make my worker nodes a little bit beefy. But let's get back to our configuration. So we're going to use the 40 gigabyte dev SDA. We've got a network. Okay, so 1969 FC. One 19 MAC address FC device name. I'm gonna name this MGMT01. Add. Just added the MAC address and the router name to or the MAC address and the host node name to my router. Now if I turn this off and turn this back on again, so turn this back on again. The name didn't populate, but it's all right. We'll do MGM management MGMT01 and click apply. All right, cool. And then I'm gonna do done on that. This should also be on. And we're going to configure this. I'm going to configure IPv4 and we're going to make that manual. I'm going to add in our information. With 10.0.0.1 and 255.255.255.0, and we don't need a gateway, and DNS is going to be 8.8.8.8. Do that is going to do save. What I need you to do is go back here, configure IPv4, and do manual add 192.168.1.19 24 192.168.1.1 and DNS 8.8.8.8. and save. Turn off, turn on. /24. Configure IPv4. /0. 88888 save. All right, cool. So, I did this a little bit different. I'm using the DHCP address only, but I'm going to use the DNS server that I want. So it's pulling the IP address from the router. All right, and then here, this is the private network. This is going to be the private network head node IP address 10.0.0.1. But to SSH to the server, I'm going to use 1.119. All right, and then go ahead and press done for that. And we're going to be a big boy today. Going to install this server with no GUI. And we already got that, new time zone, root account. Gonna go ahead and enable. Whatever, I don't care. Just working on this. We'll work on system hardening later. And all right, so I believe that we are ready to go ahead and boot and begin the installation for this server. And we'll do that. All right, so what I'm doing is modifying just this topology chart so that it just looks a little bit better. So these are worker nodes. So I'm gonna do WN01, Control C, Control V. WN02. And WN03. Then head node is actually MG MGMT 01. So I'm gonna name this Adrian, since I like Rocky, and I don't know. That's not. Just name it Bastion. Then we got Alma Brain. Management is 4 one socket, 4 CPU, 8 GB RAM. Also Rocky Linux 10, and then what else do I need to put into that? NFS 200 GIB. Virtual Management Bridge 0 and Virtual Management Bridge 1. I think that's the relevant information for Management Node 01. So let's check and see how the upgrade is going. All right, let's reboot the system. Once the system comes up, we'll be ready to use Visual Studio Code. All right, we've got our system up. We're going to bring on Visual Studio Code. Oops. That's not good. Hopefully there's not too much of that was seen. Alright, file. View. Let's get a terminal. All right, we are going to SSH admin at 192.168.1.19, right? That is the virtual management bridge 0. Type in our password, clear, and we are now on virtual management bridge. I'm going to elevate to root. And now we are ready to download and configure Warewulf. All right, so the first thing I'm going to do is download the RPM from GitHub. Import the GPG key. All right, and now I'm going to configure my firewall. Clear systemctl status firewalld. All right. All right. And then now I'm going to go ahead and edit my Warewulf configuration file. So I'm going to use vim to edit etc warewulf, warewulf.conf. But what I'm going to do first, which that's going to be cd to etc warewulf. And then we can do an ls. We see we have our Warewulf configuration file. Before we start making edits to this file, let's create a backup. So I'm going to do copy Warewulf configuration to warewulf.conf underscore $ quotation marks date space plus %, capital F, to add the date. And now if I do an ls-l, we can see that we have a backup of our configuration file. However, I did that slightly wrong. What I want to do is add underscore back underscore then the date. Okay, then I'm going to rm-rf, and I'm going to remove this file. So I'll just highlight, right click to copy into my clipboard, and then right click again to paste back into the terminal. And now if I control L, I'll clear out my terminal. And now I can do an ls-l, and I see my backup file the way that I want it. Now I'm going to use vim, my text editor, to edit the Warewulf configuration file. In here, I have the IP address for my virtual management bridge 01, or virtual management bridge 1, which is the private network that I am going to be talking on with my worker nodes. So then we're going to go ahead and add in the Warewulf ID, which is going to be 10.0.0.0 network ID. And then let's go ahead and do the DHCP, which is going to be 10.0.0.1 through 10.0.0. Why only 100 to 154 DHCP range, and why not a higher range in the /24 subnet? Cool. So let's just do starting at 100 to 150. And then gonna leave NFS on. Okay, then it's resolve.conf is true. And that's gonna be used. So let's do escape, shift, or quit. Then what I want to do is blah 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 shwoo if config. Sorry, I had to sneeze. So we have it configured somewhat. What I'm thinking to myself is sorry, I need to talk in the mic. And I'm going to be using home. Well, let's do clear cat Etsy or warewulf.conf. All right, let's go ahead and enable Warewulf using systemctl enable -- now Warewulf. And then let's add in the configuration using wwctl configure -- all. Oops, added an unnecessary space, or removed a space, unnecessary space. Shift right quit, and we're gonna do that. Configure all again. Oh my god. Line 4. Three, 4. All right, so I took out it was complaining about the values that I added and the fourth value, which was the network ID, which I'm not sure why. But nevertheless, okay, so we've got DHCP, TFTP, and NFS auto configured. Now we're going to import the yeah, I didn't set a gateway for this, so let's do nmtui, edit a connection 10.0.0.1. Oh, this access the router. I forgot about that. Anyways, I'm going to clear out my terminal. We'll make this another section. So now we have, I can do system CTL status, Warewulf D service. We've got Warewulf on and it's pretty much configured. So now what we're going to do is download our Warewulf image that we're going to be pushing to our stateless servers, and we are going to create our profile using that image, and then we are going to start creating the network so that when I create my worker nodes, they are visible to my head node and they can communicate. So we're going to download and build the image, Rocky Linux 10. All right, now that the image has been created, we're going to create or set it as the default image for the default profile. All right, so actually before we do that, I'm going to do wwctl profile list. All right, so we only have one profile and it's the default profile. And I'm not gonna add another profile right now. So what we're gonna do is modify the default profile. So what I could do is, I need to show you what I'm doing. wwctl profile list -a. Okay, inside this profile, you can see that the default profiles has no value, the image name has no value, the username has no value, the password has no value, IPMI address, all this needs to be equipped, because what we are doing is, I'm not sure if this stage will be considered baking our image or not, but let's just say that we are configuring our profile most definitely. That's most definitely what we're doing. So we'll stick with that. And let's see. We're gonna set the image. And say yes. I want to modify that property. Then we're going to set the net mask and the gateway. And then at your first test worker discoverable equals its self-register its MAC on the PXE attempt. All right, so Alright, so all right, so I got some notes from work that I'm going to be using to help me get through this a little bit as well. So I want to do wwctl image shell. Let's do wwctl profile set IPMI user and we'll do admin IPMI pass admin and IPMI net mask. So 255.255.0 on the default profile. Yes. wwctl profile set IPMI interface lamp plus on the default profile. And let's do a clear history. All right, I'm gonna unset the the hardware configs. I didn't realize that was for an ILO. I'm not using an ILO. So I'm gonna unset the IPMI user, IPMI pass, and IPMI net mask. So it looks like this configuration is just a little bit different than what would be for me in my work environment. Everything else tracks. All right, so now I think that I am ready to create my virtual machines. So if I get out of Let's take a quick break. I'll be right back. All right, I'm going to start creating my worker nodes. So let's do create VM and worker node 01. OS. Do not use any media. System. default machine. Q35. UEFI. I just saw something that wasn't correct. Huh. Oh, never mind, it is correct. Okay, so go back to create VM. Worker node 01. OS, do not use any media system. UEFI, local VM. Anyway, UEFI, Q35. We got to make this all unique or the same as the head node. Then disk. We're going to remove the disk because this is going to be stateless. No local storage at all. And then the CPU. We'll do one socket, 2 CPUs. We can always bump that and change that later. And we're gonna put that on the host. And then memory, we're gonna do 4096. 4096. And let's see. We got memory. Oh, let me see. We did the memory. We did the network. It's going to be a virtual management bridge 1 provisioning. VLAN or VLAN tag. Confirm create. Confirm boot order. Only has network. All right. So next, and then finished. All right, then I gotta configure the boot order. So I need to go here, then the options tab, boot order, and edit. And in boot order, I only want network enabled. And I want you to have priority. And now we're going to go to hardware, and we're going to take this NIC, and we're going to take the MAC address that it was given. We're going to copy this and paste it here. That was so easy. Let's just do all 3 worker nodes real quick. Worker node 01. And let's create worker node 02. Create VM. Worker node 02. 103. Next, OS. We're not going to use any media. Next, system. Going to keep this the same as the head node. OVM, UEFI. Next, disk. We're not going to use any disk. Then CPU. 2 CPUs. Using the host. Then we've got memory. 4096, keeping it the same as worker node 1. Network needs to be on the private bridge. And the MAC address is going to be auto. Then we're going to confirm. We're going to press finish. And we're going to go to that server. Then we're going to go to options. Then we're going to go to boot order. Boot order, edit. And we are going to prioritize the network boot and disable the media boot. Then press OK. Then hardware. Why are we on hardware? Oh, because we care about the network device. Then we're going to click edit. We're going to copy in this MAC address. And we're cooking up one big command. All right, so that's worker node 02. And here's the MAC. Then we're going to do worker node 03. Let's exit out of there. And we can create new virtual machine. And this is going to be worker node 03. Resource pool, don't care about that. The OS and do not use system Q35 UEFI local storage blah 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 disk stateless virtual machine. So CPU 2. What's cool is we can always bump this up in the future. Then let's go with memory 4096 and network. It's gonna be in the private provisioning. And MAC is gonna be automatic. Finish. Worker node 3 should pop up here to the left. We're gonna go to worker node 3. We're gonna go to options. We're gonna go to boot order. We're gonna edit the boot order. We're going to change the boot order process and disable IDE. Press OK. Now we're going to go to hardware and we're going to steal this MAC. And now we're ready to get that all baked in. Go back to Visual Studio Code. And we're going to build our overlay. Sounds clear. All right, so what we've got here is wwctl. We're going to add worker node 1 and give it an IP address of 10, 11, 12, and so on and so forth. We're using the hardware address, MAC address, and then we're going to do overlay build. Then we're going to view the worker nodes. Okay, so what I can see is that it added the worker nodes, created the image. Cool. I see that there's an image name, but what I don't see is a user. Runtime, hardware address. So this is not necessarily as complete as I would expect, but we're getting there. I think we're almost at a point where we're ready to test this, but what I'm thinking about is there is no user All right, so I think what I'm going to do is do the sync user command. Because if I clear and cat etc pass wd, I have the admin user in here. So, what now I believe we're ready for is to test our build. So we can go to worker node 1, go to the console, and see if the PXE in the Warewulf actually works. So it's trying to start over PXE over IP. Oh, snap. This is DHCP access denied. So it tried and got the access denied. Now it's trying over IPv6, but that's not going to work. All right, so it looks like secure boot might be what's causing. Let's do reboot. So I knew that reboot wouldn't work. So what I'm gonna do is stop the machine, power it on, and F11, F10. Oh my gosh. Stop. Yes. Power on. There we go. All right. So UEFI. Okay, just a second, please. fine. All right, so I turned off secure boot and hopefully PXE goes through. Wow, that worked. So it's pulling an image. All right, and Warewulf is downloading the image. Oh, wow. And I can log in. So I'm going to try my login with my password. Oh boy. Okay, so that's really cool. We got the server up, but I can't get in. All right, so I'm going to do the same thing to worker node 2. And then worker node 3. Turning off secure boot. Let's see how heavy my server is working now. Yeah, we're killing some RAM. All right, so we need to, seems like we need to bake in the password. All right, so I just reset. Oops. I just reset the password for root baked into my image file. So I'm gonna go ahead and start this machine and then see if I can get in. All right, cool. So I was able to get in, and yeah, I don't know, that was somewhat, I'm not gonna lie, that was actually really easy. We're gonna do a reboot, and we're gonna do a reboot. Yeah, it's pulling the image. So I got DHCP configured, I got PXE configured, I've got Warewulf configured, I've got Stateless Worker Nodes configured, I've got a management head node configured. An Alma Brain server is connected to my Git repository, and I would say that my lab environment is ultimately pretty much built out the way that I want it to be. I did not create the Bastion node as of yet, but for a night of streaming, I think we did pretty good of accomplishing majority of this topology that I am building out, and we'll only continue going on from here. But for now, I got to get some rest for work tomorrow and make sure that I learn more, that I can be great at work, keep a job, and then also take those lessons learned and bring them here to you so that we can all learn and grow together. So if you're watching this, it doesn't look like anybody joined the live stream, but if you're watching this post stream, I hope that you enjoyed this and you find it beneficial. I wasn't as good on my timestamps with the white dots and the orange dots, but We're only going to get better with time. So hope that you all have a good day, good night, and good evening. Talk to you later. Bye.